Hello. Today we will learn simple stress strain, chapter 1 of strength of material. So let us discuss. First thing in this chapter we will discuss about the failure of the materials. Nowadays you can see every product that you see nowadays are made up of some kind of material. The material may be aluminum, steel, copper and whatever. Okay. So when you are using a material to make a product, okay, then we need to check the material thoroughly. Why? Suppose I want to design a product, okay. After designing, I will go for the manufacturing of that product. So before manufacturing the product, first thing we must find out the material for the product. So for manufacturing the product must be cheaper, not be so costly. Okay, but when you are selecting the product, the material, that material should possess some qualities that will fulfill our desired design. So what kind of quality is there? So when I am using that material, so what kind of subjects will be there so that the material may fail? Okay, so suppose I am writing with a pen. So when I'm writing with a pen, suppose I started writing, and while writing I see the lid of the pen broken. So this is a failure of the pen, yes or no? So it should not have happened, but we can say this is the failure because the material that is used in the uh, lid of the pen is not having so much strength to resist the pressure that I am applying on that pen. Yes or no? So every machine, every machine or structure, whatever you see, they are made up of some members or parts, you can say, and these parts carries loads. If it is a bridge, then bridge made up of the column, then beams, so many things. And if it is a house, it is also column, beams, etc. Okay. If it is a machine, then it has so many parts. There frame is there, column, beam. So while a load is applied on those material, there may be some failure. What are those failures? Let us discuss. So the first point is any change in shape and size of the material. Suppose I am putting here any change in shape and size of the material properties of a structure, machine or part is considered as a failure. So when we are taking a material for the product design, product development, yes. So when we will apply load on that material, we ensure that there is no change in shape, no change in size. That means there is no deformation. Okay. Then when a part of a structure or machine becomes unable to perform its required function, what is that? Suppose a product is developed. Okay. Then I'm using that product. But when you are using that product, you have noticed that that product is not working properly. That means there is some defect in the any part of the product. Yes, if there is defect, there is failure. So defect means what? Defect means there is some defect in the manufacturing side, in the design side. There is maybe there is some defect in the material side. If the material quality is not good, then there will be failure. If the material not having adequate strength, the material having very low properties that are not desirable, then failure will occur. And next thing, some causes of material failure may be Selection of incorrect materials. Selection of incorrect materials. So while making the buildings, we need concrete. You cannot make the entire building with woods only. Yes. So selection of incorrect material is very important. Second one, incorrect manufacturing procedures and processing. So while making the product, we must be ensure the step-by-step procedure, and we must check the quality of the manufacturing. Otherwise, there will be fail. And the next one is the incorrect design. So these are the possible failures. A material may fail. Okay. If there is failure, then what kind of failure that may be? You see, besides many modes of failure, there are some failures that we commonly discuss. So what are those failures? First one is the bending in the beams. Beam, beam is the horizontal member that carries the axial load. Okay, while making a building or apartment, you can see the horizontal concrete beams are there, and the bending of the beams is a failure. Next one is the buckling in the columns. So you can see, suppose while making the apartments or buildings, there are vertical members which are carrying the load. These vertical members are the columns. Okay, so I can say the vertical members simply, if it is a horizontal one, then this is a beam. Yes or no? If this is a vertical one, then this is a column. And columns may bend like this. This one, failure due to buckling. When compressive load will be there, suppose load is acting here. If compressive load will act here, then due to this load, this type of bending may happen. Okay, and due to compression, this kind of failure also happen. There is some bulge eye like shape here. You can see due to compression, some portion may be swallowed, and there may be some shear. And then shearing failure is there. That means the section will be cut like here. That is called the shearing. So you can see there are some kind of failure that we discussed. There is bending, buckling, and next one yielding. Yielding means the shortening of length due to the static loading. Then elastic deflection, and next one is the fracture, obviously. So these are the kind of failure. And first thing, to avoid failure, we must select the material properly. If the material selection is proper, then there will be no defect. Maximum chances of defect problem will be solved. So first thing, while uh, making a product, first thing you design the product, then you select the proper material, then go for the manufacturing. So if your material selection is right, then in production side, the manufacturing sides, it will be okay. So your product will be developed so nicely. Yes, this is the failure of the materials. Okay, the material may bend, may elongate, may shorten by its length. So these are the failure. Okay, one example I'm telling you. Suppose I am using my bicycle. So when I'm riding my bicycle, I'm doing pedaling on that. When I am applying force on the pedaling, suppose I am applying force on the bicycle pedal, and I have noticed that when I have pressed the pedal break. If for the broken pedal, it is the failure. Broken pedal is the failure. You see, suppose you are sitting on the seat of that bicycle and that seat expanding. There is a permanent shape, change in the shape and size of the seat due to your sitting. So what that? That is a failure. That means the materials are not good to bear the loader force. Okay, so to avoid this, we must understand what type of material must be selected for the design. Okay, next, what is strength of material? So strength, the very first point we can say, strength of material is the measure of its ability to withstand and apply load without failure or plastic deformation. Suppose a load is applied on the material and the material is able to resist the load, material can bear the load, but there is no change in shape and size of the material, then the material have the adequate strength. If the material is so not able to withstand that load, there may be some permanent deformation, some plastic deformation. So the material does not have sufficient strength or adequate strength. On that basis, we can say this is the measure of the strength, the ability to withstand the failure due under the action of load is the strength. Okay, if strength is good, then the metal is okay to withstand the load. The next one, strength is the measure of the stress that can applied on the material. What is stress and what is that we will discuss. If the stress is less than yield strength, the metal return to its original shape. We will discuss these parts also. If applied stress exceeds the yield strength, the material cannot return to its original shape when the load is removed. So these 3 points we will discuss in the stress strain relationship. Okay. So next, types of loads. So on a material, different kinds of loads may act. So what is that load? Load is the external force that acts on a member of a structure or basin. So you can see if it is a beam or column, external load will act upon that. Due to the action of external load, that beam may bend. Yes, the beam may shear, some kind of failure will be there. So load is the external force. Okay. So 5 types of loads are categorized here: tensile, compression, shear, bending and torsion. So you can see this figure. This unloaded section means here is a cylindrical rod, there is no load, it is at rest, simple. This one is the tension, means you are applying the pulling force so that the material may elongate. So the length of the material may increase. That means there is a tension force which is acting on the material to expand its length. Then you can say this is the tension load. In this figure you can see the unloaded section having this length. Due to tension its length increased, but in case of compression you can see its length decreased, but it is its diameter increased. What does it mean? That means when you are compressing a material, that means you are applying the pushing force on the material, its cross section, whatever the cross section may be, but its length will decrease. If its length will decrease, the cross sectional will be increased. So this is the compression. Okay, then you can see the bending here. When moment will produce due to the force, then bending occurs. You have learned in mechanics. So this kind of bending may be happen. So where here the load is the bending load, and this is the tangential load, you can say the shear load. What happens? This type of failure may occur. So these loads are act tangentially at the circumference. Okay, so at the circumference these loads act tangentially, and these are the tangential loads. We can say the shear loads. Next one, this one, if there is twisting, you are turning this side with one moment here, you are turning this side with the opposite moment, then what happens? The material will get twist. So such kind of load is there, the torsion. And in this case you can say there is combined bending and torsion, both are there. So these are the different types of loadings. But in strength of material, when you study on the beams, we will study on the two types of loads. One is the point load and another one is the uniformly distributed load. What is point load? When a load acts on the beam section, okay, and this area is considered as a point area or this area is negligible, then you can say this is the point load or concentrated load, such that this load is concentrating at this point. But what is UDL? In the entire beam section, suppose the load is there, that means the load is distributed over some area. There is some length. Suppose this length is L and this load is W per unit length. The total load acting on this beam will be WL. Okay. So here you can say if this load is W per length, then what will happen? Suppose this length is L, the total UDL will be W into L. Okay. But here the total load is W. This is the difference. Next, what is stress? Stress is the internal resistance that is offered by the material against the deformation caused by the load. Simple. Yes. Suppose this one is the material. Suppose I have selected this section. Now tensile load P is there. How do you know this one is tensile? See, the loads are acting outwards. That means it is a force, such kind of pulling force. Yes. So this is the pulling force. So due to this pulling action, due to this tensile load, what will happen? The material may elongate. So elongation of the metal is a failure. You are doing the product development. You will, after developing the product will be used in a machine or a structure. So at that time, due to load, suppose that material get elongated, it is unable to bear the load, then this is a failure. So there is something which resists that failure. What is that? That is the stress. That means there is some resistance force inside the material which will oppose that deformation. So this resistive force counteracts the effect of this load. If this resistive force is more and more, then it can provide good resistance, so there is no failure. If this resistance force is not sufficient as comparison to the applied load, then there will be a permanent deformation and there will be failure. Okay, so how do you calculate this value? This value is calculated by sigma and this is known as stress. What is that? Resistance force per cross-sectional area. So resistance force is R. This is the internal force that is produced by the material when external load acts on this, and this one is the cross-sectional area. And for equilibrium, for static equilibrium, we consider these forces are balanced to each other, so R is equal to P, so stress will be given as P by A. Yes. So what happens? Basically, this stress can be measured, okay, by the unit. You can say the unit of the stress is Pascal, 1 Newton per meter square. So this topic is over, but let me explain what is exactly stress. Suppose a table is there. On that table you have kept 4 or 5 books on that table. But I have seen after putting 4 or 5 books in a lot, the table is not breaking or bending. But I see, suppose the table is made up of some low strength fiber or low strength of plastic, and suppose one boy go there and stood up on that table. So you observe there is some bending on the top surface of the table. Why? Because the load of the boy is very high as compared to the books. But when the boy comes down, you see the table is bent. Table is bent means there is a permanent deformation. If you see the after the boy came out from the table, you see the surface is not bent, it recovered to its original position. That means good. There is some elasticity. The material having the elasticity so that it come back to its original shape and size. Okay, so the internal force that generated by the material to withstand that load is the stress. Okay, next one, what is strain? Strain is the measure of deformation. Suppose this is the material and the length of the material is L. Suppose external load is applied here, the load is tensile. Due to load there is a small deformation, that is dl, that means the length of the uh, metal changed by dl. If dl is the deformation, l is the original length, the ratio will give you a value that is unitless, and that value is known as strain, or strain will say you what amount of deformation is there due to the load. So strain measures the deformation. So there are different kinds of stress. If you will compare the stress system, here see stress is divided into two kinds. One is direct stress, another one indirect stress and combined stress. Basically in this chapter we will study about the direct stress and the indirect stress. And what is direct stress? Direct stress is divided such as normal stress and tangential stress. Okay. So what is normal stress? So you can see uh, you can see here also. Suppose this is a body, okay, or a member or a structure. This is a member. Here the load is applied like this. You can see to this plane, the line of action of this load is perpendicular. So this load is acting normally to this plane. So this load is the normal load. So due to this normal load, a stress will develop, and that stress will develop here, and that is the normal stress, and this normal stress is sigma n. Suppose you say, and this one will be normal stress. Then you can see tangential stress. Tangential stress means its surface. Suppose this is the surface. So at this surface you can see there are two kinds of loads. One load is acting like this in this direction, another load is acting in this direction. So these two loads here, suppose you can say these are the forces. The two forces are equal and opposite to each other, and these two forces are acting on this surface. So due to this there may be shearing, and this kind of failure is known as shearing failure. So when in this direction stress will develop, you can say these stresses are known as shear stresses. Okay. So if it is a circular shaft, then there is twisting moment which will produce on the circular shaft. Okay. At that time, torsional shear stresses will develop in the circular shaft. So in torsion chapter, we will discuss briefly about this. Okay. And if it is a beam section and load is applied on the beam section, the beam may bend. There may be some bending stress that is developed in the beam section. And regarding this, we will discuss in the simple bending chapter. Okay, so in this chapter, simple stress and strain, we only focus on the tensile stress and the compressive stress and the tangential stress. So out of this normal stress is basically studied as tensile stress and compressive stress. And the third kind of stress is the tangential stress, and it is denoted as tau. We will discuss about all these stresses. Okay. Next one, what are the different types of strains? Let us discuss. So strain is the measure of deformation. If there is normal load acting on the material, then normal stress will develop. Comparison to that, normal strain will develop. So if there is normal load, there is normal stress, then normal strain will develop. And this normal strain may be longitudinal, lateral, and volumetric. What is longitudinal strain? Suppose a material is there and you are applying load like this, and this one is the material section. So this one is the length of the material. When you are applying the force like this, its length will increase. So its length will increase like this. Okay. So you can find out the change in length for original length. This one will be the longitudinal strain. For this case, there are also its width and its thickness. So no other two dimensions of this rectangular section is its width and thickness. So width and thickness will also change, not only the length. So what is the change in width? Change in width is suppose delta B divided by original B. So this is also the change in dimension by original dimension. But these values are the lateral dimensions, lateral values. So this strain is known as the lateral strain. So there are two kinds of strain. One is the longitudinal strain, second one is the lateral strain. And the last one is volumetric strain. It depends on the volume. That means this section having its volume V. Suppose after deformation, the volume changed by V plus delta V. So that means there is some deformation in the deformation. There is some change in volume. So if you measure the change in volume by original volume, it will give you the volumetric strain. So three kind of strains are there, and this longitudinal and lateral strain may be tensile, may be compressive. It depends on the load. Either you are applying the load tensile load or you are applying the compressive load. It depends.